Okay, very first problem is labeled Extra Example 3E. It says the rate at which water flows out of a pipe in gallons per hour is given by the differentiable function R. Something to remind you. Right here? That's the clue that is given on many, many AP problems. And I usually take note of the clue, but I don't focus on the clue. I just remind myself that it's there in case I need it. I often don't ever use it. The table above shows the rate as measured every 3 hours. Use data in the table to find an approximation for R prime of 12. For Unit 4, we're practicing written questions, FRQs. So one thing you want to always practice is stop at every single punctuation mark. So stop there. Don't keep reading. I'm supposed to approximate R prime of 12. So you should immediately write on your paper R prime of 12 is approximately. The rest of the wording is not too big a deal. It just says show computations, indicate units. So that's easy. Now what we need to do is have someone raise your hand and state in English words what this symbol represents. Here we go. Let's get a few more. Waiting for a few more. What does that symbol represent? Not getting a lot of people raising it. Everyone should know this is not a new idea. Like we've been studying, I mean, some English charts. Cash, credit card, birth certificate, car keys, Social Security number. Okay, cool. Okay, hands up again. Who knows? Come on, what's the English? How would you say in English, Mark, what R prime of 12 means?
The derivative of R at 12.
Perfect. 2 points for Mark. One if your hand was raised. However, let's be honest, knowing that R prime of 12 is the derivative of R isn't very helpful when I have no equation for R. So I need to know another English interpretation of that. Hence, what's the other way to say it, Carson?
The rate of flow at time equals
12. 2 points. We've got to be a little careful with that because R already is a rate. If I were making a Danica's chart, I would say I've got a rate. That rate is R itself. 2 points for Carson. And that rate is in gallons per hour. So R prime is next column over, which means R prime is a rate of a rate. Hands up, what are the units for R prime? This pattern I'm showing you repeats itself on every single AP problem you'll ever see. It's never different. It's always the same pattern. Zane?
Isn't it gallons per hour squared?
Nice. 2 for Zane, 1 if your hand was raised. So it's gallons per hour, or hour squared, either way. This tells us how fast this is changing. So it's telling you that the gallons per hour, right here, the gallons per hour, are going to change by some amount every hour. That's what R prime means. You need me to say it again, or differently. Okay, we're supposed to approximate r prime of 12. The way we approximate r prime of 12 is we simply want to calculate how fast r is changing. So I come to the table and notice that at time equal 12, r has a value of 11.4. But at time equal 9, r had a value of 11.2. Time equal 15, r has a value of 11.3. There's multiple ways you could solve the problem. They would give you credit. I'm going to teach you the most, how would you say, the most reliable, like the method that just seems to always be available and always work. And that is, let's just go from here to here. So don't overthink it. Raise your hand and tell me, from hour 9 to hour 15, how much did the rate in gallons per hour increase or decrease? Hands up. By what amount did the rate increase or decrease, Brooke, in that from 9 to 15? Nice, it increased by 0.1. Brooke found that by subtracting. She took 11.3, subtract 11.2. 2 points for Brooke, one if your hand was raised. Okay, that change in the gallons per hour occurred over a 6-hour time period. Oops, sorry. And actually, my recommendation is don't go any further. Just put in the units. So hands up, what are the units of the numerator again? Hopefully this is easy. What are the units of the numerator? What are the units of the numerator right here? The units of the numerator. Hands up. There we go. Let's go, Charlie.
Gallons per hour.
So the units are gallons per hour. 2 points for Charlie, one if your hand was raised. What are the units of the denominator? Here we go, Naomi. 2 for Naomi, 1 if your hand was raised. Okay, on test number 4, when you encounter, and you will, a problem of this kind of flavor, if you write what I just wrote, you'll get full credit. It's probably going to be worth 2 points. 1 point for having this information written down, and 1 point for having the correct units. But there's no need to reduce, there's no need to simplify, there's no need to do any arithmetic even. You can leave it just like that. And that's full credit.
And like, would it make a difference if you did gallons per hour squared?
It would not. You'd still get full credit. If you did this, for Charlie, you'd get full credit, but I don't recommend it because you don't have to. Even on the AP test, you can stop right here and receive full credit. So you don't want to keep going because it just takes a little bit of extra time. It also risks an error. And the part that's painful is if you go one more step and you make a mistake, they take the point away. Like, you had the point right here. You were done. Like on my test, this would be 6 points for test 4. But if you go one step further and you do something wrong here, you will lose 3 points. So don't go further. Just stop. Question? Please.
How do you know when it's far enough?
You know it's far enough when the only thing remaining is addition, subtraction, multiplication, division. So there's no variables left, there's no calculus left to be done, it's just arithmetic, you can stop. And for the rest of the year, as we do more and more written problems, I'll just keep showing you where I would stop. And to be fair, it's often kind of surprising how early you can stop. But that's what you want to do, it's the best strategy.
So this problem would not be solvable if RFT was not differentiable.
No, even if it was not differentiable, you could still make an estimate. It's again an example of where I didn't really use the clue.
Okay.
Your point?
Sorry, you said this would be 6 points on the test. What points is it missing? Is it missing a like internal point or?
Oh, the way they award points simply varies from problem to problem.
Okay.
And so I'm just going off of the fact that they have had problems like this kind of flavor on AP tests for years and years and years, and they've typically awarded 2 points.
Okay.
On the AP test, so I award 6 on mine. So.
Okay.
Questions? Super Cougar. That's it. Keep going. Extra example 3F. Go. I'll just walk through and stop me if you have a question. So do the next example. Let's label this extra example 3F. Stop me if you have a question. So this is a good example of how, even though a calculator is allowed, you really don't want to even pick up your calculator. Oh, so when they say, the problems are pretty simple, and so you literally could do it in your head. Just their requirement is they want to see on paper what you're doing. So when they say show the computations that lead to your answer, they're saying show this. That's all. Good question, Debbie.
Sounds Japanese.
People are not writing anything. Okay, I'm looking for R prime of 7. R prime of 7. So no 7 in the table, that's not a problem. I'm just looking for what's happening between hour 6 and hour 9. And between those 2 hours, I have a rate that goes up. So I have to show my computations. So I have 11.2 is what the rate ended up being at hour 9. 3 hours earlier, the rate was 10.8. And I don't want to do any computation here just to avoid a possible mistake. Units of the numerator, again, are gallons per hour. On the bottom I've got 9 minus 6. Those units are hours. And I just stop, and on test 4, that would be worth 6 points.
So the reason it's an approximation and you're able to do that is because it doesn't give you the exact value of the hours, 7 hours, and then the gallons per hour during that. So that's why it's an approximation, is because you can't find exactly what it's at.
That is correct. We don't know exactly what's happening at hour 7. In fact, two per Davis. What we're really doing here is this right here is the computation of a slope. We are calculating the slope. Let's get ready to answer. What kind of a slope are we calculating? A secant or a tangent? Haley, what is it? Secant. Point if your hand was raised. So we are calculating a secant slope. It's a secant slope of R from or for the time interval 6 to 9. So that's what we're calculating. If we try to draw a picture of this thing, it's like if we try to draw what R look like, R seems to go up and then R kind of comes back down. What we're doing is we're saying we want to find out how fast R is changing. We want to estimate how fast R is changing, say right here at time equals 7. But we don't have any data that would allow us to do that. So what we do instead is kind of like the mean value theorem. We go find a secant slope that's nearby and say, well, the slope of that red line's decent approximation of maybe what that slope is. That's all we're doing. Please.
So then if we did have the information that Dave was talking about to calculate exactly at t equals 7, then that would become a tangent slope.
That is correct. And more, really to find it, oh, yeah, please, Josh.
They really picky on like the units. So if you did like G per hour instead of GAL per hour, would they work out wrong?
I think you'd be okay. I personally would be nervous, so I'd put GAL, but I think they'd give it to you.
Just spell it
grams per hour.
Just because it could look like grams, but I think they'd give it to you. Anybody else? Back to, look, Jacob's question. Hey, look. The only way to truly find R prime of 7 is if you have an equation for R. If we don't have an equation for R, we can't find R prime of 7. So if we don't have an equation for R, the best we can do is do a secant slope to approximate a tangent slope, always. So that's all we're doing. We're just using, and secant slope means average rate of change. Tangent slope means instantaneous rate of change. So we're using a average rate of change to approximate an instantaneous rate of change. Cool, next thing. Okay, so it's the exact same situation, but it's a new question. It says approximate the average rate. Key difference here. I want to see how many people can notice. The wording on G and the wording on F, well, no, let's. I just told you that right here, that what we are finding here is we are finding an average rate of change. So we just found an average rate of change of R for the time interval 6 to 9. That's what we just found. Item G kind of sounds like we're finding the same thing, but it's not. Who can explain the difference? Naomi's in. Who else? Haley? Like, what is different between finding an average rate of change for a certain time period? That's what we did here. We found an average rate of change. Come on. We found an average rate of change of R for a time period. And that's how we approximated R prime. But here we're being asked to find an average rate. What's different? There we go. Ammon, Ben, you're in. Point if I say your name. Jacob. I got Naomi. Josh. Ammon. Got you guys. Derek, what do you think?
Is it just talking about the R of t rather than the R prime of t?
Yeah, I gotta think of how to phrase this. So here we're approximating R prime.
Yeah.
We're doing it by finding, on average, how fast R is changing. So here we're paying attention to how fast R is changing. We're noting that R changed by, like we kept going, we'd say, okay, R dropped by 0.4 gallons per hour. And R did, the rate did that over a 3-hour time period. That's how fast R is changing. It's an average rate at which R changes. Here, we're not trying to find the average rate at which R is changing. We're trying to find the average of R itself. Okay? Give me 1 to 5 how clear that feels. So I can see if I need to say it 4 times. So let's pay some people tickets. Just simply raise your hand and say as best you can what I just said. Like, what is being said here? When we did the green, what are we really doing versus what they're asking us to do on G? Let's go, Haley, go ahead.
It's asking for the rate at which the rate is changing, and then on G, it wants us to find just the average rate instead of the rate is changing. It just wants us to find the exact rate at that point.
That's very well said. I'm going to just try and summarize what you said again to hopefully make it clear for everyone. I'll pay you a ticket in a second. So it's back to Danica's chart. We have the rate, which in this case is R of t. And as Haley just said, in problem F, they wanted to know, on average, how fast is R changing? How fast is R changing? They wanted us to go over here and find the rate of the rate. They wanted an approximation for R prime, how fast R is changing. But in G, they don't want us to do anything with this. They want us to just average this. Anybody else want to say it for a ticket? Okay, cool. Okay, so for item G, we need to do some math that you have all done since about, I don't know what year they teach this, but it feels like, 7th or 8th grade. We need to find the average of R. That's what it says, find the average rate. The rate in this case is R. So we want the average of R for the 24-hour time period. Please raise your hand if you remember from previous math. It's probably an ACT question typically. How would you find the average of something? How do you find the average of something? There we go. Yeah, don't overthink it. It's not anything right.
Well, you add one together and divide by the number.
So I add things up and I divide by how many I added up. So how many new? 0.2 per right. Okay, the difference here is they do give a little bit of extra instruction. It says using a midpoint Riemann sum with 2 subintervals. So I need to draw some brackets. Raise your hand if you know where I draw the brackets. Here we go. Let's go Porter.
0 to 12, 12 to 4.
So if you knew that we needed to draw brackets like this, Please give yourself a point and 2 for quarter. Questions? Okay. I think you all can do this. So within each bracket, how many values of R am I going to focus on? Raise your hand. So in each bracket, Ty, how many am I going to focus on? Ty and Mary?
1 per bracket.
1 per bracket. Which one, Ty?
For the first one would be 6, the second one would be 18.
Nicely done. So I'm going to go to time equals 6. Focus right there. Points for Ty, 1 if your hand was raised. Okay. Give me 1 to 5 how comfortable we are so far. Good point for the room. I still got, not quite doing a very good job yet. We've got to get a little more clear. We're trying to find the average rate. Here are all the rates. One way to do it would have been to add up each of these. And then divide by how many we added up. That would be one way to find the average rate for the 24-hour period. Give me 1 to 5 if that makes sense. Point for the room. Okay. I'm guessing it feels a little weird as to why we're doing this midpoint thing. Like why midpoint? Like why not just add those up and divide? They will never give you credit on the AP test for using that method. They're trying to teach you a different method. So let me show you the different method. Put your pencils down. Don't write anything down. Like what you've written so far is helpful, but don't write anything for a moment. What I'm going to do is I'm going to take the 10.8. Funny. Benji says, why use a method that works when you can choose a whole new method that you don't know anything about and don't have any idea if it even works? I will show you why we learned the other method, but that is valid at this point, totally valid. So let's see, I take 10.8. I want to add that to 10.7. And then I simply want to divide by 2. What I'm about to do is not going to seem logical, but stay with me for a minute. Okay, I'm actually going to multiply this by the width of the subinterval, which is 12. Stay with me. And multiply this by the width of the subinterval, which is also 12. Okay? Because what I'm doing here is I'm doing an integral. This is the integral from 0 to 24 of R of t dt. Because we've done that. You practiced this on the buff packet. If we were doing a midpoint Riemann sum of this integral, we would have taken R, right here, the value of R, and we would multiply by the dt, or the width of the subinterval. And the same thing for the next subinterval. That's simply how a midpoint Riemann sum is done. That was the buff packet. So you should not have any trouble understanding why this integral can be approximated by doing this. Okay, so for a moment you've got to forget about average rate and just show me 1 to 5 if you are comfortable that this integral can truly be approximated as we've done. Show me 1 to 5. If you haven't done the buff packet, this will not make sense because that's what the buff packet was all about. We're pretty good. Point for the room. Okay, what I'm trying to show you in a roundabout way, I totally understand that, is that if I had if I had 100,000 different values of R, if I had 1,000,000 different values of R, and I want to average them, I have to add them all up and divide by how many I add up. Well, integration includes the process of adding. So what I'm trying to show you is you can use integration to find an average. And you can actually use integration to find an infinite average. So you can theoretically add up an infinite number of values of R and divide by that infinite number of values of R and end up with the average of R. So the only reason, so we're not really doing something new, we're just extending what you already know to a more, how would you say, precise tool. Instead of just adding up a few values of R, we're getting the potential to be able to add up an infinite number of different values of R. That's why we're integrating. Right here you should be able to see we're adding up values of R. It's just that we've got this extra 12 thing that seems to be kind of in the way. But we are adding up values of R. Questions? Please.
And it's multiplied by 12 because that's the size of the brackets, right? So if you get it from like 0 to 6 and then 6 to 18, like the difference between those would be wrong.
So, hold that thought, I'll get back to it. You're okay, 2 points. It's easier to show in a minute. Okay, so I've got, how do I say this? I want to add up different values of R, divide by how many I add up. But I want to use an integral to do it. So here's how I make it work. I integrate R from 0 to 24, and then I simply divide by the time period. Multiplying by 1 over is the same thing as dividing. I'm going to divide by the time period, so now come back over here. So if I put a 1 over 24 here, that means I have to put a 1 over 24 here. But that means that 12 is a common factor of both terms. So 12 can be factored out. If you don't say it out loud, I want to see how many can see it. Raise your hand and tell me. We are now adding 10.8 plus 10.7, and then we're multiplying by 1/2. So what are we really finding? Like, just look at this box and tell me. Ignore everything else. Just raise your hand and tell me, what did that box just compute? What is being computed by that box? Hands up, come on. What is being computed by that box? Hey, wait a second is the right reaction. Go ahead. No, it's perfect. This green box is simply the average of these two rates. So what I'm trying to show you is I can use an integral to find an average. That's the big idea. I can use an integral to find the average of anything. Anything. Sure, you have, no, I'm serious. Like, you have a formula that tells you an infinite number of values of whatever. If you integrate that formula and divide by the width of the integral, you have just calculated the average of all those different values. So we can use our calculator to do like the average of 100,000 values, like in a second. So 2 for a paid and 1 if your hand was raised. Please.
Is this more or less accurate than the old method of just add everything and then divide by the number?
They're the exact same method. No, they're the exact, like, what are we doing here? Are we not, no, stay with me, stay with me. Are we not adding values together and then dividing by how many we added? Keep talking, Jim.
But so far in this unit, we've been talking about the more more numbers that we use to find an average, the more accurate the average gets. But in this one, we're only using 2 compared to whatever 10 we would have used otherwise.
Nicely said. The only difference is they said, hey, just show me you know how to do it with just 2. But we're still just using an integral. So if we simply increase the number of subintervals as much as we want, the accuracy of the average just goes up and up and up.
So then if we made the number of intervals the same as the number of things that we would have been adding with our previous method, then it would give us the exact same.
Then we give you the same method.
But in our calculator, we don't know exactly how many.
Yeah, we let the
How do we
calculator-
know how
Go
to
ahead.
multiply by? Like 1 over 20.
I got you. I'm going to go back to Haley's question first. Hey, so you were saying, Haley, like, say again your question.
I was wondering why we're multiplying it by 12 instead of like in the above bracket where we multiply it in the difference from the beginning to the point and then from that point to the other point.
Oh, we actually didn't. On a midpoint sum, we always said, what's the width of the entire subinterval? The 6 just happens to be in the middle of the subinterval. But the duration of the subinterval, the D of t, is still 12. That's what we did in the above. Is that okay? Questions? Please.
Another one. I think I missed somewhere. Where did we get that 1 over 24 from?
I just told you that the way I can get an integral to compute an average is I can take advantage of the fact that the integral is going to add stuff up. But I've got to find a way to divide by how many I add up. And basically I'm combining this with this to compute how many I need to divide by. Let's do another example. So let's clear this off. Let's go subintervals like this. So if I want to find the average of R, I'm going to take the integral of R from 0 to 24. Don't write this down, just watch. I'm going to do the integral of R from 0 to 24. I'm going to divide by 1 over the time period, like that. But now I'm doing it with 4 subintervals. So we'll go down the rows here. So this is not part of the integral, so just write it down, 1 over 24. Now we're, oops, I left off the dt, sorry. So there's a dt right here. Okay, I need to compute the integral. We'll start with, we'll go with Davis. So what should I write? I'm thinking, I'm integrating r of t dt. So what gets written here, David?
10.43.
Say it louder.
10.43.
Nicely done. 2 points for Davis. Parker next.
And then times by 6.
Oh yeah, my bad. Sorry, it is 6 x's, not 3. This is 6. Next one, Parker.
And then do 11.2 times 6.
2 points. Questions so far? Brooke?
11.3 times
2 points. And then Naomi?
6. 7.3 times 6.
So then again, if I factor out the 6, So Zane, now that I factored out the 6, what is this red box truly calculating?
The average of all those sums.
Yeah, I'm taking the average of 4 rates. That's all I'm doing. I've got 4 rates here, 2 for Zane. 1, 2, 3, 4. This is divide by 4. So this is the formula right here for calculating the average of anything. Please.
I'm just checking, so we should always multiply with the time period, we should multiply it like by the width of the interval and not the difference between the 2 different times.
Are you looking at this number here, Haley? Are you asking about this number?
That's number
The 6. The 6 is always the duration of time for the subinterval. Is that what you meant?
Yeah.
I'm still not helping you, that's my bad.
Are they the same thing? Like if you multiply like 0 to 6 with 6 slope, but what I did in the other thing is I would just do the difference between 3 and 9 if you used those 2 values. Is that the same?
Oh, I got you. You were looking here, right?
Mm-hmm.
That's a good question. 2 points. Don't do it your way.
Okay.
The reason is when they give you tables that are not symmetric, your way won't work. Is that okay? Yeah, always go by the width of the subinterval. Does that answer your question? It's good work.
We probably asked this question in another class, but is there like a left and or a right Riemann sum? Are any of them like more accurate than the other?
The trapezoidal is typically going to be the most accurate. Midpoint, depending on the shape of the curve, can actually be very accurate. Left and right just depends on the curve. So, Benji.
And we're still using like it would still use the same units, so it'd be like gallons per hour over hour.
Good question. Hey, 2 for Benji. Look up. You have to put units on this. Actually, this one did not say to use units, but it's actually common that they would. You get the wrong units, you're going to lose 3 points out of 100 on test 4. So don't say it out loud. Hands up. Who knows the units? There's 2 ways to find the units here. Who knows the units? Hands up. Who knows the units? Tyson?
Gallons per hour.
So we are finding the average of R. And because R has units of gallons per hour, the average of R has to have units of gallons per hour. Okay, 2 points for Ty. Raise your hand if you knew. Point. Questions? Answer your question, Ben. Please.
So where we're getting that 1/24 fraction is from our, what is it called? Integral sign.
Integral.
Which is from 0 to 24.
Yep.
We just made it 1 to 24.
1 over. The
Right.
formula, here's the formula you all must memorize. If you want to make a flashcard, feel free. The average of any function is computed by taking the integral of the function. So it's the average of f for some interval, like a to b. You integrate the function from a to b. And then you multiply by 1 over the width of the integral, like that. And if you choose shorter and shorter, subintervals, the accuracy of the average gets better and better, to the point where if the interval is an infinitesimal duration, the average is perfect.
So, just kind of, not a shortcut, but a rule of thumb or something to help you remember. The 6 over 24, that will always be equal to the length of your interval over the change in x.
True.
Okay.
Good points. Now, if you simply remember the formula, you're all set. Like I've tried to show you kind of where the formula came from. You're not going to be tested on that. So if you want to just memorize the formula and use it, you'll always get full credit on a problem like this. On test 4, this problem would be likely worth a total of 9 points. They give you 1 point, as always, for writing the integral. That's pretty common. They would give 1 point for having the right computations, which is the, you could just stop here. I wouldn't go further. Don't factor out the 6. Like, I'm just factoring out the 6 to prove to you that it's working. You don't have to. And then 1 point for the units. You don't have to work anything out. Don't even pick up your calculator. Just leave that and move on, and you get all 9 points.
So that blue box could be your answer.
That blue box should be your answer. Yeah, 2 points. Yeah, don't make it, don't do anything else. Just leave the blue. Questions?
So your answer is this.
On written sections, don't do that.
No, it's true. That's why initially everyone's like a little bit like uncomfortable with the written section. With time you realize it's the better section.
I literally can't even
Otherwise,
remember.
learn how to solve.
If you're adding subtracting dividing.
No, it's just that it's actually a much more realistic, I say, it's a more realistic picture of what you even do in a real job, where you don't do this by yourself. That's what you have a computer for. You do the thinking, let the computer do the grunt work.
If you can't, don't do it.
Okay, moving on.
If you don't have to, you don't.
Calculus of the written section of calculus has to be like I see it.
Okay, it says we're supposed to find a right Riemann sum approximation of this integral. So we want to write down the integral. Go ahead and write it down. I want to see how well we can do without any prompting from me. So we'll go with Mark Allen's next in the rotation. So Mark, what would you have me write down? What would you have me do? Or I don't know. I gotta write something on my paper.
Okay, so you draw 3 brackets, right? From -3 to 3, and then from 3 to 9, and then 9 to 8.
Points for Mark. Well done. Charlie, you're up.
Then you would do, it would be -3. Would it be -1 times 6?
2 points for Charlie. You are making a small error. Let's see if Porter can fix. Part of what you said right, part was.
Oh, wait, it's the right.
Keep going, doing great.
1.
There we go.
Would be 1 times 6.
Nicely done.
And then the next one would be.
So plus, yeah.
Yeah, plus, and then it would be 1 times 6 as well.
Nicely done. 2 points. Oh, please, Gabby, please.
I don't know what I'm missing from it, but why is it 1?
You're doing just fine. You okay if I talk you through it?
Yeah.
Good. So we're doing this integral. We're integrating f. And what the AP test writers did, of course, was they thought, hey, I know how we can trick people. We won't give them a table. We'll give them a graph. But the idea doesn't change.
There's no units.
So I got to do 3 subintervals. Are you okay with that?
Yeah.
Awesome. I got to go to the right side of each subinterval. So, Gabby, tell me the value of t that is on the right side of each subinterval.
It's not average.
I don't know where I'm supposed to be looking.
You're good. So my subintervals begin at time equal -3. Then it goes to time equal 3. Then they go from 3 to 9, and then from 9 to 15. Those are the 3 subintervals. Does that make sense?
Yeah.
Okay. So we're supposed to go to the right side of each subinterval. So what is the time on the right side of each subinterval? I'm not doing it very well. This is me. Where does the first subinterval start?
-3.
Perfect. Where does it stop?
3.
Good. So 3 is on the right side of the first subinterval.
Okay.
With me?
Where do you get 1?
Right. So, but I'm supposed to take the value of f at that time.
Okay.
So what's the value of f at that time? 1.
Okay.
Is that better?
Yeah.
You good? That's 2 points. You could have done this, Gabby. It might have helped. We could have said we're finding f of 3 multiplied by 6. We're going to add that to f of, what would go here, Gabby? Help me quick.
9.
Multiplied by. So you're just doing this. You're just doing this. You're taking values of f at different times, and you're multiplying by dt. So what goes right here, Gabby? 6. And then the next one, Gabby, go ahead.
F of 15 multiplied by 6.
Nicely done. Sorry, I'm staying with you just to make sure.
Okay.
What goes up here on this line, Gabby?
-1?
Do you see why?
Yeah.
2 more points. Well done. Questions? Good work. Anybody else? That's it. Stop. Don't go any further. It's a written question. Just stop.
And no units.
No units given, no units specified. Please.
So if you wrote the green, would you get credit?
Ah, take it for that one. Look. I want to see how many can. You don't. Because you have to resolve this.
Okay.
Yeah, you have to find the f of 3. The way I think of it is, I don't know how to say it. Just, I know from experience you can't stop there. So, please, Kate.
Do you have to write the green?
You don't have to write the green.
Okay.
No, the green was just trying to clarify what I was thinking. 2 points for you. Jacob.
So I'm trying to do the thing that we did in, I don't remember, the buff homework where you have to like draw the boxes to show, you know, what like the bracket boxes. I'm getting a little confused doing it, so could you like demonstrate how you would do it?
So really, these are my brackets right here.
Right.
Keep going. I'm not helping.
I think he wants you like to draw the.
Yeah.
Oh, you mean when I draw the rectangle?
Yeah.
Oh, gotcha. No, you okay if I talk you through it?
Yeah.
It'll help you see it better.
Mhm.
So, how would you draw, like, where's this on the graph?
At 3, 1.
It's right here,
And then you would go over to the left until -3, and then that becomes a box.
like that.
Yeah. And then you have another box for the interval from 3 to 9. And it's from 9 to 15 that I'm getting a little confused. You just drop
Because you go down.
It's
So
just
then,
negative.
Is that last box an overestimate or an underestimate then?
All 3 boxes seem to be,
So the left one's over, middle's under, but what's the right?
yeah, the left is definitely over because it's way too much positive. The middle one is way too low. The one on the right is way too much negative. So it's way too low, then it would be way too much negative. They won't ask you that, but that's what it's doing.
It's hurting my eyes.
It is hurting my eyes.
Yeah, that's what I'm saying.
They don't, the rectangle idea is really, really useful when everything's positive. As soon as things
Yeah,
go.
it gets negative, I'm like, I
Yeah,
don't
as soon
know
as
what-
things
I don't
go
know what that is.
negative, it's not great, it's not a very, it's like a lot of graphs.
So,
They're useful to a point. As soon as you have negatives on your graph, it's not very useful. They won't ask you.
I don't know which part to shade on. That's the part.
You shade right here. But the ideal would have been this. This would have been the ideal integral for that space. Would have been 0. Because you would have counted this, that I'm drawing now positively, you would have counted this negatively when you integrate in the ideal sense. So that would have come out 0, so we're way too negative, our estimate. -6 is much, much too negative. It should have been 0, would have been the ideal. Would that help?
Yeah, okay, I see now.
Okay.
Thanks.
Cool, next one. Okay, I want to see how many people can raise their hand and speak about this problem. All I want you to do is read the problem and raise your hand when you can explain what's the difference between R of t and Q of t. Hands up. Well, take some time to read, sorry. Read it first, and as soon as you feel like you've got it, be prepared to explain the difference between R of t and Q of t. So the first part's no different. It just shows the same table, gives the values of R. The key phrase is right here. So who knows this is a common AP thing. Like, it happens a lot. They'll give a table, they'll call it R. They'll give an equation, they call it Q. The names will change, but the idea won't. What's the difference between table R and equation Q? Hands, come on. There we go. What is the difference? They're going to expect you to know the difference because it happens a lot. What's the difference between table R and equation Q? Benji?
Q is approximate, like it's integral.
Q is not an integral. That's okay. The word I want all of you using is this. Q is a model. Q is a mathematical model. Keep going.
I'm kind of lost.
You're okay. 2 points so far. Go ahead.
You're saying
Go ahead, Evan.
Q of t is an approximation of the exact values we can get from R of t.
2 points for that. Where do the numbers R, like, if you read the problem carefully, tell you where R comes from. Like, where did R come from?
R comes from measurements at specific points in time, so that means Q of t is our best guess at, like, kind of connecting the dots.
You ever hear that? Say it again.
Q of t is our best guess at, like, connecting the dots and saying this is probably what it was. This is probably what the graph looked like if we were to give instantaneous values at every single point of the graph.
Oh, that's perfect. 2 points. R are measurements. Like, they just measured at different times, and they wrote them down. And then some mathematician or engineer comes along, some scientist, and he says, hey, based on those numbers, I think I can create a formula that will duplicate them somewhat. It'll never match perfectly. But this is really what, okay, in the real world, this is the only reason we have math. Because we want to make a model so that we can then design something. That's the whole idea. Because you don't want to design without a model. It's like hard. It's hard with the model, but it's easier. This is the real data. There's no error. Like, they measured it. Or measured it? How do you say that? Measured? Apparently I say it wrong. B8 was all over me last night. Seriously, if you say it wrong, it's not measured, it's measured.
How do you say this?
Days of the week?
Yeah, like say
Monday? Like that? How do some people say it?
Monday.
Really? Monday? Monday, Tuesday? Okay. Hands up, hands up. What's the advantage of Q? Come on, hands. Why did they come up with a model? We got the data. Cougar already said it, but why do we have a model? Hoping for a few more hands. Why do we have a model, bro?
Can you get a better average because you have all the like instantaneous values?
How many knew that? Point 2 for Brooke. Now that we have a formula, we can do more math. We can use more math tools. With just data in a table, we're kind of restricted. So that's why they come up with a model, because then you can use a lot of math tools to help you make predictions, whatever. Okay? It's really common in AP questions to have data and a model. Get used to it. Data and a model. In this case, we're supposed to use the model to find the average rate of water flow during the 24-hour period. So because Q is the rate of water flow, Q is the rate of water flow, we're supposed to find the average of Q. So here's where we're using our new formula. We say the average, write this on your paper please. The average of Q. We're not finding the average rate of change of Q. We're finding the average of Q. It's for the time period 0 to 24. That's what we're finding, the average of Q for that time period. Not the average rate of change of Q, but the average of Q. Those both get tested. That's why I keep saying it over and over again. We're going to do this by integrating Q. And then multiplying by 1 over the width of the integral. Please.
So should we write Q if he gives those the actual
Formula?
Yeah.
Oh, good question. Let me look. Here, two, look, here, look. Don't write formulas on the written test. Use the names. When you write the formula, you risk writing it wrong, and you lose multiple points. So it's better just to write the name. Okay, if dt is infinitesimal in length, that will be a perfect average, given that the model is, we assume the model is perfect. It's not, but anyway. So. But that's the purpose of the model, so we can average a whole bunch of values. Question? So now you grab your calculator. You grab your calculator. Oh, Benji, please, question.
So like when I said QP was, it had like an integral.
Oh, you were thinking kind of ahead to what they were asking.
Yeah.
Yeah, Q of t itself is an integral.
Yeah.
But to find the average of Q, we are definitely going to integrate Q. Is that better?
Yeah.
Good work. 2 points. You grab your calculator. So put Q into your calculator. Here's a keystroke a lot of people don't know. Please stop. Don't ever use the slash in this class for divide. Always use the fraction bar. So you want it to say 1 over 79. If you don't know how to get your calculator to do that, it's alpha F1 or alpha Y equal. So you want to get the fraction bar. Don't use the slash. So you do alpha and then Y equal, and that gives you the fraction. So make sure yours looks like mine. If you use the slash, I promise you. I had a student in this morning who was very frustrated because she's like, I can't get this one problem to work. Everything else works. Because she was using the slash. Don't use the slash.
Wouldn't it be the same thing if you put it like in parentheses?
It is. It's just, now it just takes more, I don't know if the keystrokes are the same or not, but it's just safer. You see it better.
It looks nicer.
It looks nicer. But you're right, it would be the same as long as you parenthesize it properly. Anybody else? Please take the fraction. Do alpha and then Y equal here. And it should say N over D. You see that? No worries. Did you get it to work?
Oh, yeah.
You got it? Okay. Anybody else? Raise your hand if you have this type. Show me who has it. Show me his point. Okay. Go to the main screen. Second quit. Do the fraction bar again. We want 1 over 24. Just warning, this is one of the places where people often lose 3 points on the test. They forget the one, actually they end up losing 6 points. They forget the 1 over 24, so don't forget. I always remember that I have to divide when I'm finding an average. So I've got to have the 1 over 24, so I'm dividing. So now it's math 9. And just 0 to 24. Y1. There's the average of about 100. No, it's more than 100,000. Because you go all the way to 24, I think that's about 2.4 million samples. Questions? Alpha trace.
Oh, yeah.
You're good.
Yeah, they're about 2 seconds, which is actually kind of slow.
Somebody else?
My favorite fact is just a quote, don't calculate. Mr. Smith is above all.
We all are. 'Cause, I think it's actually quite amazing that all the calculator is a pile of silicon's made from sand, right?
Yeah.
So, pile of sand.
Quote Mr. Smith, go back. Calculators are just a pile of sand.
Just reorganize. That's all it is. It's quite interesting to think about it. It's like, what do we got in here? Like some sand, some copper. Reorganize.
Special, I call it
You
special.
know their elements.
Special, I have more than sand.
Oh, yeah, for
It
sure.
just turns
This is some really
pixels on and off,
expensive
right?
sand.
It's only to interpret what it means.
You're saying that's 20 more.
Very expensive.
Question. Cool. Next one. So you can do that one. Go. Do number 2. Go, go, go. Oh, awesome. Everybody pause for a minute. The bell's going to ring, so pause. I got to answer Brooke's question. She was spot on. I'll pay her a ticket for this. So it's a written problem. I can't stop here because I still have to demonstrate that I need to do some calculus. So I grab my calculator, read the number. What was the decimal, Brooke?
10.78.
I write that down. That is required. I notice it says indicate units. What are the units, Brooke? We are finding the average of Q. Q is the rate. So Q is measured in gallons per hour. So this has to be gallons per hour. So this problem on test 4 would earn you 9 out of 100. And here's how the points would be awarded. Most likely 1 point here. If all of that is perfect, any flaw, you lose 3. You don't get hard, it's like 3 or nothing. 3 points if this is correct to 3 decimals. 3 points if you remember the units. Good question. Please.
What if you don't do 24 minus 0? If you just like
Oh,
find like
if you write 1 over 24, that's okay. You don't have to say minus 0, but you do have to have the 1 over 24. Good point. 2 points for that. Good job, you guys. Have a really nice break. Don't do any yellow.
You know the song I Kissed a Girl and I Liked It? Yes. I heard that song as a child and I was confused out of my mind why it sounded like a female talking to a and then I grew up. It wasn't so weird anymore. I lost somebody.
You're like unsensitive innocence.
Something changed.
My sister, that's her favorite song right now, and I'm just like, this looks lucky.
Oh wait, it's lighter. I took out the entire last unit and I just have like this massive 2-inch binder. It's just full of calculus. Oh, here's a slope. I don't know how you have that.
Good job, you guys.
Yeah. That Calculate my AvgROC is every ounce saved is every second additional less.
Yeah. I have a couple of people who wanted to come. Have a good break. Is there, you too. Is there any, like, should I start a brunch or look at either way. I'll watch. You're welcome. Good job, folks. Thanks. Thanks. You as well. See you guys. See you, Cougar. Good job. Well done.
Thank you.
Merry Christmas.
You as well. Nicely done.